Okay, YouTube, I think I got the figures I was looking for. So I use this Mannix D CFM 8906, called their CFM Master 2 airflow meter. It's a pretty nice unit. It has a little anemometer there, and there's a temperature probe someplace in the airstream. What I did was record just feet per minute, because that's the units this comes up in, but you can change, you could use meters per second or miles per hour, knots, and if you calibrate it to your duct size, you can actually get CFM. But what matters is all of those are just calibration factors, they're constants. So I ran the airspeed from 585 up to 720 feet per minute, and you can see the temperature. As the airspeed increases, the temperature drops, or the delta temperature. So this is the inside temperature minus the outside temperature. And then if I just multiply this times this, I get a number that's roughly calibrated to BTUs, or heat. So at the slowest speed setting, I had the highest incoming temperature, but I was only getting 24,394 coming in. When I sped it up, I still got a pretty good temperature in about 26,000, but if I sped it up a little more to where I started dropping the temperature, I actually got 27.6 K, and at full speed the temperature drops even more, and now I'm down to 27.1. So my sweet spot is kind of right about here. I thought it was here before, but looks like I have to go a little bit higher. You can kind of think of speed. This is your current, how many cubic feet per minute or feet per minute of air. This is your voltage, so higher voltage, and if you just take amps times volts, you get watts. So this is very similar to what your maximum power point tracking in a photovoltaic panel. So you're doing the same thing. If you pull the voltage down a little bit and increase the current, at some point you hit a maximum heat, and if you go over that, you run the current up, but the voltage starts falling quickly. So you want to try to find that point where the product of the airflow times the temperature rise gives you the highest number. And you can see it's quite a significant percent. And with solar heat, you never have enough. So you want to get all you can. When the sun's shining, you got to get as much heat as you can. I got a new ideal speed point on my system, so I'll keep it set there. One of these is really handy to have. Before I got this meter, I could measure the temperature. I would put a thermometer in the airstream, and I kept going to lower and lower speeds because I got more temperature, but not that much of it. And the idea is you want to move more air and still keep the temperature rise as high as you can, and that gives you the most heat coming in. So I just wanted to pass on how I do this. I imagine there'll be some HVAC gurus that are, telling me I'm all wrong, but at least from first principles, if I just take the airspeed times the temperature rise and use that as a figure of merit, that's, I could convert this to BTUs, but it's still whatever factor you multiply these by to get BTUs, you multiply all those numbers by the same factor, so it's the relative magnitudes that matter. And so now I've found kind of my peak point there, and I'll leave my fan speed at that setting. So I thought I'd pass that on. If you have any comments, put those in the comment section below the video description. I'll see if I can find a link to this. You can check out some of my other solar heating videos. I have a playlist on that. You can subscribe to my channel to get updates. And as always, thanks for watching.